Hi everybody, welcome back. How's it going? So last time we introduced two things really, the transpose operation, which is just, it makes a vector look a little bit different. You could think about it as either a column or a row, and so it changes a column to a row, or it changes a row to a column. And a matrix, which is really just a table of stuff, okay? So it's going to be numbers, and we'd write, technically if we had a matrix, say M, if we let M be a matrix in R, say this one would be, we'll say 2 by 3. Okay, that could represent this matrix above because there's 2 rows and 3 columns. That's why I wrote 2 by 3. So its dimension is 2 by 3. So if we have that, then we can represent stuff in this table. And the R is just saying they're real numbers at negative infinity to infinity. So what table of stuff do we have in the context of our regression? Well, disregarding the y values, which we may or may not have depending on what information we're looking at, we definitely have a set of x vectors, okay? So we can think of, say, we have person 1, we might have x, which I'll say x1. We're going to call them column vectors, okay? It's just the normal thing to do. So if we had, say, 3 pieces of information about them, maybe the first value was 10, the second value was 2, third one was 4, okay? These are just, say, the first was the age, the second was the height, whatever. It's just different pieces of information about these people. And so the first component's always going to be that same type of information, whether it's age or height. It's going to match for all people. So if we had x2, notice my notation, this thing is saying it's like a different thing, okay? It's like a different person. So x2, that is equal to, well, their first component is whatever, the same type of value that this first thing over here is, but it's their value. Okay, so maybe it's 5, maybe the second one is 4, and the third one is 1. Okay, whatever. These types of things, these 4 and the 1, they're the same type of thing, they're just different values. Same thing, 2 and 4, same type of thing, different values, and 10 and 5, same thing, okay? So if we have this notion of different people like before, we still had that earlier, and now we have all of our information about that person into this vector, and actually, just to stick with the linear algebra stuff or the linear regression stuff from before, we'd probably call the first thing 1, okay, because that makes it easier as we saw before. So the first thing is 1, and then the rest of them is whatever values they happen to have. Then we can think about our table of stuff as, I'm just going to call it x, okay? And that's usually the notation. I'm going to say that x is equal to, well, how would I want to write this? Well, normally we think of rows as different people, okay? If you're familiar with SQL at all, or anything tabular notion like that, is we think of rows as different people or different objects. And so I want to do that the same way. So how would we do this? Well, I'd really write this as x1 transpose, right? If I go down like this until I get n things, okay, so we have n different rows, n different objects, n different people, okay? So that thing transpose, because then what we have is if this was the first one here, this is x1, well, I could replace that with this information. So this would be 1, 10, 2, 4, and then say if n was 2, if we only had these 2 people, then the second thing would be this x2 here. So this would be 1, 5, 4, 1. Remember, the transpose operation takes a column and turns it into a row. So then that is our table of stuff. It is our design matrix. It's all of the information that we're going to use for our inputs. We also have the y values, which we'll look at later. But this thing's really useful because it's really our table of stuff that we're going to use for a bunch of different calculations. And this is very important in all of machine learning. Not always is your input a matrix. If just to give some intuition, if it's a picture, well, a picture might be just a two-dimensional thing like this. But if there's 3 different colors, RGB values, it's actually, you can think about it as a list of matrices where it would be, this is the first thing is a matrix, the second one's a matrix, the third one's a matrix. So RGB, this would be R, this would be G, This would be B if we had 3 different matrices. But ignoring that, I'm not going to get worried about that. I'm just letting you know that we don't always in machine learning look at just a 2-dimensional thing. A lot of the time we do, and in linear regression we definitely do, is we think about this matrix of one row is a person, second row is a person, and other people might use different notation, like the first column is a person, and second column is a person instead, but this is the most common thing to do. So the final thing I want to talk about here is the dimension of this matrix. So what in particular does this thing always look like in terms of its format? So we would write, this is in, that's the wrong thing, this is in R. So the first thing is how many rows does it have? Well, we have n rows. We have n different many people. Apparently, my thing is optimizing memory usage. There we go. So n by, well, how many columns do we have? So that would be how many different parameters that we have. That is always going to match the betas, right? Because this thing is 1 because that was beta naught times 1. And then this is how many different things that we know about the person. Okay, so really, if I say that we have p parameters, so if we say we always, our beta dimension, so if we have beta is equal, or I'll just say beta is in our p, okay, we have p parameters, then this thing is going to be n by p, because that's how many columns that we have, which is also going to be how many parameters that we have in this linear regression model. Okay, hopefully that made sense. If not, I'm going to clear some of this stuff up. It's a little bit rough and kind of sloppy at this point on purpose. If you didn't catch everything, that's totally okay. And don't worry, keep it up. I'll see you in the next video.